And time to stare into space. We do it with Dylan Storey. Thanks very much to the Auckland Stardome Observatory. Good morning, Dylan.
Good morning.
Good morning. And the big astronomy thing this week was the transit of Venus on Wednesday.
Yeah, so that seems to be the astronomical talk of the week. So I went down to the Stardome Observatory and was helping out there. And there were thousands of people through. I forget how many thousand, but there was some poor person standing at the door counting, and there were thousands.
Wow!
And so we had a lot of members of the Astronomical Society had brought their special telescopes and were out in the courtyard. And there was the Stardome and Astronomical Society's new big solar telescope mounted to one of the big telescopes in the telescope domes.
Yeah.
Hooked up to a camera, so feeding into a computer, and so pretty high tech there. And what else? There's planetarium shows every half hour about the transit and all the workings of it, and there were various other presentations and people around. And it was cloudy.
Well, it wasn't cloudy for the whole time. Now, I guess if you were down south, you were dealing with snow flurries and that sort of thing, and it was definitely no chance further south. But I was,
apparently at Mount John they were snowed in.
Yeah, exactly. So, and I was a little bit worried. I was like, the weather, in Auckland is probably going to be raining. But we did get around about sort of half an hour, around about 11 o'clock on Wednesday morning, and Stardome had sent me some of those solar glasses. Just they look like 3D glasses, except you've got the solar protection there on the front. And I was here at work and stepped out onto the balcony, and I thought, I'll take a look. I'm not expecting to see much here, especially without a telescope or anything. Put the glasses on, and first I couldn't see anything because they block out so much light that you can't see a damn thing. But then found the sun, and then which was this orange globe, which was quite amazing because it looked like a planet because it didn't have this bright halo around it, sort of distorting the shape of it, so I could see a definite sun, and then right there down the bottom, a black speck, that being Venus.
It's amazing, isn't it? Amazing.
I was blown away, and so a lot of people around here at work didn't even know it was happening, and I'm like, hey, put these on, take a look at the sun. They're like, what? And they're like, oh, man, what's that? What's that little black dot? And suddenly we had this crowd that had started to form around us. Everyone wanted to go on the glasses, and I thought, this is great.
Well, that pretty much sums up, I think, why I love doing even normal telescope presentations at the observatory on Wednesday nights. Because of that reaction, you can learn all the theory about astronomy that you want.
Yeah.
And then when you see people actually seeing something with their own eyes, it's like, wow, it's actually there.
Especially something that's not on a computer screen, not a projection, not sort of second hand. We were definitely seeing that with our own eyes, and it was so definite. It wasn't like, I think I can make it up. Yeah. I'm not sure if I can see it. No, it was definitely there,
Yeah. Well, no, you got in at the lucky time because there was about 30 or 40 minutes in the morning. When we got brilliant views of the transit, and throughout the whole day, I could safely say that there was probably 2 more gaps of about 30 seconds where it could be seen.
Pretty good though on the east coast of the North Island at Tolaga Bay, where they were having the Transit of Venus conference.
Yeah, they were lucky. Yeah, must have been a freak weather. But we could see. I mean, there was just clouds rolling in all the time, and there'd be sort of clear patches, and then they'd go past the sun and not over it. But as you see with those glasses, they're the shade that they block out absolutely everything except for the full sun.
Yeah.
So you see the full disk of the sun. So a lot of people would put them on, and it's all black.
Yeah.
Walk away in disgust.
Well, I guess
they need to be that strength.
Yes, apparently a welder's grade strength. Do you know much about that? There's a certain certain specification for welder's glass, and it's right up there with that.
Welding's a very hot flame, but it's a lot closer to you. So I guess the strengths work out about the same.
Yeah.
But the solar telescope that the Stardome's got is really interesting. It's a big, proper telescope, and it's got a proper solar filter, and you can set the filter to it's a hydrogen alpha filter, which means it filters at the frequency of the hydrogen alpha molecule, if you want to go into it. But you can set it to slightly different densities, if you like. So you can set it to either pick up the brighter light from the surface of the sun or the dimmer light from the edges of the sun.
Yeah.
So when you set it to the surface, you can see this amazing texture of the surface of the sun with all the sunspots and all the swirling flames and everything, and and you can see all these churning currents, and then you set it to what the guys do there in the society is then they set it to the outside, so you're picking up all the prominences, all the solar atmosphere, everything around it.
Yeah.
And then they make a composite image, and I have to say the image they got in that clear 40 minutes on Wednesday morning was absolutely stunning.
Cool.
You could see all the stuff, and then you could see all the things spurting out the side of the sun, and you could see Venus going over the front of it. So it was outstanding.
That's awesome. One thing that puzzles me, and hopefully you can explain it, is that when I was seeing it with my naked eye, through the solar glasses, Venus was coming through in the bottom right-hand corner and going right to left.
Telescopes flip it upside down.
So most of the images that we're seeing online on the news sites and everything, Venus is at the top. And it's going left to right.
Yeah, it's a bit hard to know, because if there's anything that have been streamed off a live feed from the northern hemisphere, they'll be, they'll have their telescope tipped up another way because the Earth is facing another way. They're leaning another way there. So they might have corrected it for the way we'd see it if we were standing up.
Right. But
no, to us in the southern hemisphere, it was on the bottom. But if you look at it through a telescope, it will flip it up the other way, just by nature of the mirror.
So, okay, that's right. So if you're watching it in America with solar glasses, it would be at the top.
Yes.
Oh man.
But if you're looking at it through a telescope in America, it would be at the bottom again. But it's all relative. I mean, if you're if you're on the equator or somewhere where the sun's going to be directly overhead, there's no up or down. It's just above you.
Yeah. So where is it?
Let's say you're on the equator, you're facing north. It will be to the south side.
Okay. Yeah. I get it. Yeah.
It's just that to us the sun is down to the north.
Yeah.
So we look at it that way when we're standing up. I mean, there's no up and down in space as such.
Sure. So yeah, I see what you mean. So if I was to watch it in sort of upside down from Auckland, I would have got the northern hemisphere effect. Okay. Yeah. I understand. Excellent. Hey, that was that was
constellations are upside down to us.
I was just about to say that was amazing, Dylan. Thanks very much. But I was like, thank you, universe. That was great. Well done.
Yeah, well, we'll give the universe a clap.
Good stuff. And it sounds like it was a great time down at the Auckland Stardome Observatory, where hopefully a lot of people got introduced to all the various things that go on there. That's for sure. Dylan, people can continue the conversation with you on Twitter, twitter.com/Dylan Storey. We'll see you next time. It's now 7:52 here on